All right. Example number 5, by our traditional approach. We need to write and balance an equation. If you've studied biology, you probably have this one memorized. In photosynthesis, carbon dioxide reacts with water to make glucose and oxygen gas. We haven't studied the nomenclature for the formula of glucose, so I just gave it. But we do know carbon dioxide, it's a nonmetal plus a nonmetal, so the prefixes tell us the subscripts. So carbon dioxide would be CO2, and water goes by its common name, not dihydrogen monoxide, so that's H2O, and that's going to make glucose, which is C6H12O6, and oxygen gas, right? Plants do that to create oxygen. CO2 gives us carbon on the left. Carbon is in glucose on the right. I need 6 carbons because glucose has 6. So over on the left-hand side, I'm going to put 6 in front of CO2. For hydrogen, I have 12 on the right-hand side in glucose, so I'm going to need a coefficient of 6 in front of water. And then it works out to make the oxygens balance. I'm going to need to put a 6 in front of O2. The number, the unit, and the chemical that I was given was 10 liters carbon dioxide. So that's where we're going to start. And notice that's 3 sig figs on the 10. So 10 liters of CO2. Place that over 1. Since we did not get the given in the form of moles, the first step is to convert it to moles. So I'm going to put liters of CO2 down here and moles of CO2 up top. For liters, we're going to use 22.4 from the mole triangle, and for moles, we use the number 1. Now that we have moles of CO2, we're going to rely on the coefficients from the balanced equation. For every 6 moles of CO2, we're going to have 1 mole of glucose. So we've now successfully converted from 10 liters of CO2 to moles of glucose. But we weren't asked for moles, we were asked for grams. So we need to add one more step, and that is that for every 1 mole of glucose, we're going to have the molar mass, which I forgot to copy from the previous slide. I believe that was 180.18 grams of glucose. And if I run that through my calculator, I'm going to end up with 13.4 grams of glucose. The liters of CO2 cancel out, the moles of CO2 cancel out, the moles of glucose cancel out, so indeed only grams of glucose are left. Last example. Same problem, but by the alternate method. We're going to have 6 carbon dioxides plus 6 waters yield glucose plus 6 oxygens, and the molar mass of glucose is 180.18 grams. Can't have any naked numbers, gotta make sure we put a unit on it. All right, we're gonna start with 10 liters of carbon dioxide. Place that over 1, and then in our alternate approach, we're gonna copy the unit and the chemical that we were given, and up top, we're gonna put the unit and the chemical that we're asked for. We are asked for grams of glucose. We need to put 2 numbers here. One of them matches the units from the mole triangle for grams, that's molar mass. So up top, I'm going to put 180.18 0.18 because that's the molar mass for glucose. We also need to put the coefficient in the balanced equation for glucose, which is a 1. Yeah, there was nothing written there, so we understand that to be a 1. Down on the bottom with liters of CO2, the number on the mole triangle is 22.4, and the coefficient in the mole triangle on CO2 is a 6. And if I run all of those numbers through my calculator, I'm going to get 13.4 grams. Yeah, it really is grams of glucose. The liters of CO2 cancel out, leaving us just grams of glucose. Whew. That was a lot of stuff. As far as which approach you should use, the traditional approach or the alternate approach, it is entirely up to you. You should do the one that makes the most sense to you.